to our mathematics lesson. I am Skhulile Ncube, and this lesson is proudly brought to you by Gauteng Department of Education. How is term 2? It's been a long time, isn't it? Right, this is our first lesson for term 2. What are we going to do today? We're going to look at the geometry of straight lines. It's basically revision. We've done these things in grade 8 and grade 9. So today we are revising. Geometry of straight lines. Please make sure that you have your book with you and all the things that you need, pen, pencil, and calculator. You need all those things, okay? Let's be ready for our lesson. Right, let's start. Today we're going to revise geometry of straight lines. Like I've said, that's the main objective. We want to revise geometry of straight lines. That's what we're going to do. In grade 8 and 9, we have done this topic, so it is revision. But before we move any further, grade 10s, I want us to do this activity. I want you to try. Calculate the size of angles marked with small letters. So we have angle Y and Z. X is already given there. X is 25, so don't worry about X. You may use X to find Y and Z. Let's find the value of Y and Z. I'm going to give you 2 minutes. Let's try. No, not 2 minutes for each. So it's 4 minutes. Okay, let's try. Welcome back, grade 10s. Remember our WhatsApp line is 063-629-3655. Remember our WhatsApp line. Let's communicate during the lesson, grade 10s. And then if you have questions, make sure you ask now. And then when I get time, I will manage to answer your questions. Please just the name of your school and your question. Okay? Right. Even your input, please send us your input. Right. Now, what did you get for the value of y? What is the size of angle y? What did you get? What can you say about angle y? What type of angles are those? Angle y and angle x are alternate angles. They are alternate angles. Do you see that? We have these parallel lines, EC and AB. And then BE is the transversal. Do you see that? And then also forming the letter N. Remember, in grade 8 and 9, we talked about fan. Okay? The F for corresponding angles, the U or the C for co-interior angles, and then the N or Z for alternate angles. You see that? So X here and Y are alternate angles, so Y is equal to 25 degrees. Okay, and then how to define Z? There are many ways we can find Z. Let me start with the first one. If you check this angle, which angle is that? Oh, AED, they are on a straight line. And then this right angle, and Y and Z are adjacent angles on a straight line. The right angle, which is yellow there, the Y and Z are adjacent angles on a straight line. They add up to, adjacent angles on a straight line add up to what? 180 degrees. And then you write your reason. Adjacent angles on a straight line. Right? And then we have the Y. We can substitute there. And then we can find Z. We transpose. Becomes Z is equal to, what is 90 plus 25? Should be 115. So it's going to be 180 degrees minus 115 degrees. And then what do you get? 180 degrees minus 115 degrees. It should be 65 degrees, isn't it? Right, 180 minus 115, 65 degrees. So it means Z is 65 degrees. Okay? Someone could have said, no, I have these two lines here, this line, AB and EC. They are parallel lines, and then AD is the transversal. So angle A, this angle, and then this angle are corresponding angles. So it means angle A is equal to angle Z because they are corresponding angles. That's another way of doing it. And then someone can say, oh, this angle also is 90 degrees. So these are complementary angles. Complementary angles. So it means Y plus Z must give us 90 degrees, but we have Y, so it's going to be 25 degrees. This is Z, not 2, plus Z is equal to 90 degrees. And then we say 90 minus 25 to get our Z, which is 65. These are the different ways we can find those angles. Okay? Now, how are we going to have our lesson? We're going to discuss two types of what? Of lines. We're going to start looking at the intersecting lines. And then after looking at the intersecting lines, we're going to look at the parallel lines. Geometry of intersecting lines. And then after that, we're going to look at the geometry of parallel lines. Let's start with the geometry of intersecting lines. The first one, adjacent angles on a straight line. We have done this also in our baseline activity. The adjacent angles on a straight line are, you can just raise your hand and say the answer. What can you say about the adjacent angles on a straight line? They are supplementary. Okay, they are supplementary. What does that mean? When I'm saying supplementary, what does that mean? They add up to 180 degrees. Supplementary angles add up to 180 degrees. Complementary angles add up to 90 degrees. Remember that. Okay, supplementary angles add up to 180 degrees, and then complementary angles add up to 90 degrees. So we can say we have this angle here, D2 and D1. See D1 and D2 there. If we add them, we get, if we say D1 plus D2, we get 180 degrees, and then we write our reason, adjacent angles on a straight line. Okay, let me just give you 1 minute to write your short notes. Let's try to do that. Welcome back, grade 10. Remember our WhatsApp line 063-629-3655. Right, now we're going to use what we've discussed here to answer the following questions. We said adjacent angles on a straight line add up to 180 degrees. Adjacent angles on a straight line are supplementary. Okay, right. Now we say they have a common vertex. This is the common vertex here. They have a common vertex. And then they also have a common arm. Okay, these are adjacent angles on a straight line. Okay, right. Given the following diagram, we have angle. Verify if points A, B, and C are on a straight line. Verify if points A, B, and C are on a straight line. Give a reason for your answer. We have been given angle B1 and B2. Are points A, B, C, or is A, B, C a straight line? Can you try to verify this? Maybe in 1 minute. Let's try to do that first, 1 minute, then we'll discuss after that. Right, welcome back, greetings. I really hope you managed to get the answer. What do we do? What is 143 degrees plus 36 degrees? It is 179 degrees. So it means this angle, this whole angle here, is not 180 degrees. So it means A, B, C are not on a straight line. If they were on a straight line, then these two angles, B1 and B2, is supposed to add up to 180 degrees. So we're saying adjacent angles B1 and B2 are not supplementary, hence points A, B, and C are not on a straight line. Okay, right. I really hope you're trying grade 10s to do these questions. I'm going to be giving you a lot of questions. I want you to try. Remember, we are revising. Okay, I want you to try before I give you the answer. Let's try to do that. Please don't just sit and watch the video. No, it won't assist you. You have to try to answer the questions, and then you check your mistakes when we're doing the marking. I'm going to give you the next question. Right, the next question says, given the following diagram, determine the size of angle N2. Let's do that in 2 minutes. Right, welcome back, grade 10. Did you manage? Okay, let's mark our way. Even if it's wrong, don't worry. You try. We learn from our mistake. Okay. Determine the size of N2. So M, N, O, they are points on a straight line, or you can say MO is a straight line. So it means N1 and N2, they must add up to 180 degrees. There's one thing I want to emphasize, grade 10s, right? Is your statement and reason. Statement and reason. You just write your statement only without the reason, you won't get marks. So what do I mean by that? You have your statement. We're saying N1 plus N2 is equal to 180 degrees. This is the statement. And then why are we saying that? Why are we saying N1 plus N2 is equal to 180 degrees? These are the angles. Why do we say angle N1 plus angle N2 is equal to 180 degrees? Because these two angles are adjacent angles on a straight line. Okay, right. And then N1 plus N2 is equal to 180 degrees. And then we substitute, we have N1. And then we solve for N2. We know how to solve equations. We don't solve for X only. This is our unknown. We're solving for this. So what do? We subtract 114 degrees from both sides of the equation. Okay, we subtract. Some people talk about transposing, whereby you bring 114 degrees to the right, then becomes negative 114. And then you have N2 is equal to 180 degrees minus 114, and then N2 is 66 degrees. Okay, right, that's what we're supposed to do there. Please try to write the corrections as I explained, because we may not have enough time to cover everything. Okay, right. I want to give you the next one. Then the third one I'm going to show you, okay? Right, let's try the next one. Then the third one I'm going to show you. Let's try this one for 2 minutes. Let's try. Right, let's do this together. Grade 10, A, D, and B are points on a straight line. D1 is equal to X. Determine the size of angle D2 in terms of X. Right, we have two angles here that are adjacent angles on a straight line, D2 and D1. So we're going to say angle D2 plus angle D1 is equal to 180 degrees. Statement, the reason adjacent angles on a straight line. Okay, see that? Okay, and then we can start now looking for our angle D2. D1 is X, so where there's D1, angle D1, we're going to put X. And then what do? We subtract X from both sides of the equation, or we just transpose X to the right and then becomes negative X. And then D2 is equal to 180 degrees minus X. This is D2 in terms of X. This is D2 in terms of X. Please try to write corrections as I explain. But if you feel like I'm moving fast, please let me know. Okay, please let me know. But let's continue. Remember WhatsApp line 063-629-3655. Let's go to the next one. Pairs of complementary angles. Another situation where we have intersecting lines. Pairs of complementary angles. Complementary angles add up to 90 degrees. Remember that. And then I said supplementary angles add up to 180 degrees. Okay, like this angle Q1 and angle Q2, they add up to 90 degrees. These are complementary angles. But Q1 and Q2 are complementary angles. They add up to 90 degrees. Do you see that? Okay. And then I'll give you time to write short notes. You don't need to write everything you see on the slide. Okay. Just short notes, then you'll be fine. Then Q2 is equal to, Q1 plus Q2 is equal to 90 degrees. Just repetition. And then if two angles are adjacent, then the angles are adjacent complementary angles. If they are adjacent and complementary, they are adjacent complementary angles, because angles can be complementary without them being adjacent. A good example for a right angle triangle. Let's say this is 90, right angled. If this angle is 30 degrees, then this angle is 60 degrees. 60 degrees and 30 degrees are complementary angles. They add up to 90, but they are not next to each other. They are not adjacent. Do you see that? But here Q1 and Q2 are adjacent complementary angles because they are next to each other. Right, and then Q1 and Q2 are adjacent since they share the common vertex and the common arm. We write the complement of Q1 is Q2, or vice versa. Q2 is the complement of Q1. Let me give you 1 minute to write short notes, the points that you think there are the main points, just that, for 1 minute. Right, welcome back, grade 10. Let's continue. Right, pairs of complementary angles. Calculate x if the complement of 3x minus 4 degrees is 2x plus 24 degrees. Let me do this one like I promised. What does that mean? These angles are complementary angles. So it means that if we add them, they must give us what? 90 degrees. So it's going to be 3x minus 4 plus 2x plus 24 is equal to 90 degrees. The good thing is that outside the brackets we have positive 1. So positive 1 does not change anything inside the bracket. So we can deal with the like terms. 3x plus 2x, what is it? What is 3x plus 2x? It's 5x, isn't it? And then negative 4 plus 24. What is negative 4 plus 24? We find the difference between these two and take the sign of the bigger number. So it's going to be positive 20. Okay, so we have 5x plus 20. This simplifies to 5x plus 20 is equal to 90. Then what's the next step? We transpose or subtract 20 degrees from both sides of the equation. We transpose 20 to the right, becomes negative 20. What is 90 minus 20? Is 70 degrees. Okay, 90 minus 20, 90 degrees minus 20 degrees is 70 degrees. Then what do we do to find x? Solving equations, divide by 5, divide by 5. You see that? And then x is equal to 14 degrees. We didn't say these angles are 14 degrees. No, it is x. And if you're asked to find these angles here, where there's x, you're going to put 14. And then where there's x, you're going to put 14. Then you can find the size of the angles. Okay, so this is our answer. If there are any questions, please just send us a WhatsApp 063 629 3655. And any input that will make our lessons better, isn't it? Please send us your input. Your input has helped us a lot, and please continue doing that. And then angles around a point, I'll just discuss this. I'm not going to give you an activity on this one. And then you can just write your short notes as I explain. Adjacent angles in a revolution. You can write that one down. Adjacent angles in a revolution add up to 360 degrees. There can be 2 of them, there can be 3 of them, there can be 4 of them, there can be 5 of them. So they are around a point, like these angles A, B, C, they are around a point. Okay, that's a revolution. Okay, and then we're saying A plus B plus C is equal to 360 degrees. A plus B plus C, you see, it's a complete revolution, is equal to 360 degrees. And then what reason do we write? We say angles around a point, you can write it like this, or angles in revolution, like that. Okay, right, 1 minute to write your notes. Welcome back, Cretans. Let's continue. Right, we have dealt with which angles? Adjacent angles on a straight line. We've talked about that. They are supplementary. We've talked about complementary angles, and then angles around a point. We're still on the intersecting lines. I want us to move to parallel lines, but we still have another type, which is what? The vertically opposite angles. How do you see vertically opposite angles? They have a common vertex, but they do not have a common arm. We said adjacent angles on a straight line, they have a vertex and a common arm. But the vertically opposite angles, they don't have a common arm. If you check, A and B are adjacent angles on a straight line because they have the common arm there, the CD one. But what about A and C? What about B and D? They don't have a common arm. A and C, they do not have what? a common arm. Do you see that? These angles are vertically opposite. Okay, and they are equal. Vertically opposite angles are equal. And then that is A. Let me highlight A and C. Do you see that? The cross lines. Once you see the cross X, these are intersecting lines forming an X there. So A and C are vertically opposite angles. And then B and D, also they are vertically opposite angles and they are equal. B and D, they are vertically opposite angles and they are equal. Right, we have looked at different angles, adjacent angles on a straight line, complementary angles, angles around a point. Right, we are learning them in isolation, sort of one by one. But it does not mean that they cannot exist in one diagram. Like in this diagram here, we have vertically opposite angles A and C. What can you say about A and B? We have talked about this. What can you say about A and B? A and B are actually adjacent angles on a straight line. Do you see that? A and B are adjacent angles on a straight line. Which other angles are adjacent angles on a straight line? We can talk of, where is it? Can't find me. Okay, identify other adjacent angles or that are supplementary. This means adjacent angles on a straight line. We have C and D. They are adjacent angles on a straight line. We have A and D. They are adjacent angles on a straight line. We also have B and C. They are adjacent angles on a straight line. Do you see that? Because CD there is a straight line. Okay, right. So you should be able to identify all those angles. Right, and then we have this question. I'm going to explain this because I want us to move fast to the parallel lines, but it does not mean that we must not understand this, okay? I'll try to move slowly. AC and DE are straight lines. You can even highlight them. These are straight lines, okay? You can even highlight AC. We're talking about AC. This is AC. And then this is DE. They are straight lines. Very important. That intersect at O. So this is the common vertex here. O1 is 6x plus 45 degrees. We have that one there. O3 is x plus 80 degrees. We have that one there. I've seen some people that do this. They look at the information. This is the information. They ignore it. They don't even read the information. They go straight to the diagram and to the question. You can't do that in Euclidean geometry. You have to read the information. The clue is in the information. AD is a straight line. Think of what? The geometry of straight lines. Okay? They intersect. We're talking about geometry of intersecting straight lines. See that? It guides you. Read information before you what? Before you answer the question. Determine the value of x. So it means O1 and O3 are vertically opposite angles. And then we write that O1 plus O3 is equal to, where they are vertically opposite angles, meaning that they are equal. So O1 is equal to O3. See that? Statement and reason. Now, we are coming back, applying our algebra. We are solving an equation. Right? What do? We subtract x from both sides of the equation, or we transpose, becomes 6x minus x. And then we transpose 45 or subtract 45 degrees from both sides of the equation. Whichever method you are using is okay. It's going to be 80 minus 45. And then we get 6x minus x is equal to 80 minus 45. And then 5x is equal to 35. And then how do we get x? We divide both sides by 5. Divide both sides by 5. So x is equal to 7 degrees. X, not the angle. If you want to find the angle, then you have to say 6 times 7 plus 45, or x plus 80, which is 7 plus 80. Actually, this one is easier. So it means this one is 87 degrees. The angle is 87 degrees there, because our x is 7. Okay? Right, we are done with the revision of intersecting lines. Now we're moving to the parallel lines. And then we still have 22 minutes. We'll try. But we're going to look at the parallel. Right, when you talk about the parallel lines, which angles do you think of when it comes to parallel lines? Because they will tell you that AB is parallel to CD. Once they say that in the information, you have to think of the angles, geometry of parallel lines. Which angles should I expect here? I should expect corresponding angles. I should expect alternate angles. I should expect co-interior angles. So these are the three types of angles we want to discuss. Okay? Right, let's go there. What are parallel lines? When I say parallel lines, what are these parallel lines? We need to understand that. So a parallel lines lie in the same plane and do not meet or intersect. They do not cross each other. They are equidistant from each other. This is a good example. The railway line. This line, my line. This line, okay? You see that? The distance between them is the same throughout. You see, you're talking from Johannesburg to Pretoria, the distance between these two lines is just the same. Otherwise, if the distance is not the same, they were going to meet somewhere. Let's say I have these lines there like this. If I extend them, you see, they're going to meet somewhere. But parallel lines, they maintain the same distance between them. They are equidistant. Okay? They are at a constant distance away from each other. That means equidistant. And then example, railway lines are at a constant distance from each other, hence they are parallel. Okay, those are parallel lines. But now, how do we represent them in mathematics? How do you represent them in geometry? We just draw the two lines and indicate using the arrows. You see these arrows there? Those arrows show that AB is parallel to CD. You see lines with those arrows like that, it means the two lines are parallel, not equal, parallel. Because you can have two lines that are parallel but not equal, like this line and this line, they are parallel, but they are not equal. See, parallel but not equal. If they are equal, we can use this line. Remember that. The arrow is for the lines that are parallel. And then these lines, short lines, are for the lines that are equal. Okay? Then how do we write this in mathematics? Instead of writing AB is parallel to CD, a whole sentence like that in mathematics, we have a way of doing things in mathematics, mathematical language. We just say AB is parallel to CD. This is enough to show you that AB is parallel to CD. Just these two lines there. AB is parallel to CD. That's how we write it in mathematics, okay? Right. And then we have another special line when it comes to parallel lines. Otherwise, we may not talk about these angles corresponding, alternate, co-interior, if this line is not there. Which line do you think I'm talking of? The transversal. Transversal. Okay? Right, transversal. I didn't give you time to write notes. Let me see if there are any notes that you may write there. Okay, let me give you 1 minute. Sorry for that. Just 1 minute. Short notes. You can draw your lines, put your arrows, and just indicate these short notes for 1 minute. But welcome back, greetings. Let's continue. Right, we said the line transversal. EF is transversal. This is the line that cuts the parallel lines. Okay? Okay, sometimes I won't be giving you time. Like this one, you don't need to write a lot of things. EF, transversal, the line that cuts the parallel lines. That is enough. So this one is the transversal. Let's talk about corresponding angles. I'm going to use this diagram. How do we identify corresponding angles? I know we talked about this thing last year, but corresponding angles, how do you identify them? In the word find the corresponding angles, they form the letter F. Right, like if you check here, they are the red ones. Let's check the red ones. They are on the same side of the transversal, and both of them are above the parallel lines. Okay? It's not always above because your parallel lines can be like this. And then you can say both of them are above. Let's say with corresponding like this, corresponding like that. Both of them are on the left of the parallel lines, something like that, if these lines are parallel. Okay? Right, they are on the same side of the transversal. That's the first pair. We have the purple ones. You see that? They are on the same side of the transversal, and both of them are below the parallel lines. Okay, don't need to write a lot of things here. Let me just explain. And then we have this. You see that? The blue ones. Both of them are on the right-hand side of the transversal, and both are above the parallel lines. These are corresponding angles. And then we have the green ones. You see, both of them are on the right of the transversal side, transversal line, and then both of them are below the parallel lines. This is how we identify the corresponding angles. When the diagram is like this, you can say both of them are on the left of the parallel lines, or both of them are on the right of the parallel lines. But you see that they are on the same side of the transversal. Okay, same side of the transversal, same side of the transversal, same side of the transversal. This is how you identify the corresponding angles. Okay, right. So let's just discuss this. I'm just reminding you. And then corresponding angles. If AB is parallel to, we know what this means now. If AB is parallel to CT, then the corresponding angles are equal. Which are these corresponding angles? Can you try to identify all the pairs, and then we're going to discuss after that. You can discuss in pairs, okay, in pairs to find the corresponding pairs. Right, let's discuss in pairs. Right, which angles are corresponding? Let me give you just 2 minutes to do that. Discuss. Welcome back, returns. These are the pairs that I got. A and E, their corresponding angles. Do you see that? Did you get that? A and E are corresponding angles. Right, remember the reason. Oh, I didn't talk about the reason. We say corresponding angles, and then ignore the equal sign there. Corresponding angles, AB parallel to CD. You have to include the lines that are parallel. Okay. Right, and then also here, ignore this. Sorry for that. And then B is equal to F. B and F goes with B goes with F. They are corresponding angles. And then which other pair? We have D and H. They are corresponding. We have C and G. They are corresponding. You can mark your work there. Okay. This is how we identify corresponding angles. Remember that. Okay, let's go to alternate angles. What is to alternate? Alternate. Alternate is to change, isn't it? Alternate, changing. So what are they changing? They're in the different sides of the transversal. Different sides of the transversal. Like this H4 and G2. This is the G, this is the H. Right, H4 and G2 are alternate angles, and alternate angles are equal. I think this time I forgot to emphasize that. Corresponding angles are equal. Alternate angles are equal. Okay, we have that letter Z there. You see that? And then both angles are within or between the parallel lines. They are between the parallel lines on the different sides of the transversal. And then we also have these two. You see that? Letter Z or N in the fan. Remember fan? Right. So we have G1 and H3. Those are alternate angles. Different sides of the transversal. Do you think you can identify the alternate angles in a diagram? Let's try to do that. But let me show you the other diagram. It can be, where's the other diagram? Still the same diagram. No, it's fine. Now, if AB is parallel to CD, then the alternate angles are equal. Now, let's try to identify two pairs of alternate angles. It should be just the internal angles, the ones between the parallel lines only. Because some books, they talk about exterior ones, okay? Let's deal with the internal ones, right? And then those two pairs, which ones? Which angle and which angle and which angle with which angle? Let's do that in 1 minute. Right, welcome back, Cretans. Let's discuss this. So we have which angle? We have angle B and angle H. These are alternate angles. Which other pair? We have angle C and angle E. These are alternate angles. Do you see that? Okay, right. So we have identified the other pair is fine. Okay, this is how we identify alternate angles. After this, I'm going to give you an activity. Okay, right. Let's go to co-interior angles. Co-interior angles lie on the same side of the transversal. And then please take note. What did I say? I said corresponding angles are equal. Alternate angles are equal. Please, in capital letters, please, co-interior angles are not equal. Co-interior angles are supplementary. They add up to 180 degrees. Co-interior angles are supplementary. Please write that down. Write that down. Co-interior angles are supplementary, meaning that they add up to 180 degrees. Please don't make that mistake. And then, so which ones are the co-interior angles? Remember, we use the U or the C. So we have here H4 and G1. These are co-interior angles. If you add this angle and this angle, we must get 180 degrees. And then we also have these two. If we add this angle and this angle, we have 180 degrees. Do you see that the co-interior angles are on the same side of the transversal, but now they are between the parallel lines, unlike the corresponding angles. Corresponding angles are on the same side of the transversal, but if they are above, both of them are above the parallel lines. But these ones, they are within or between the parallel lines. That's co-interior angle. Okay, they add up to 180 degrees. They are not equal. Okay, right. And then we have this diagram. They are supplementary, the co-interior angles. Let's identify the two pairs. Can we do that in 1 minute? Which ones are the co-interior angles here? 1 minute. Right, welcome back. Which are the angles that are co-interior? We have angle B and angle E. The reason that we write, we say co-interior angles and then state the lines that are parallel, AB, parallel to CD. So B and E, do you see that? And also we have C and H. They are not equal, but they are supplementary. These are co-interior angles. You think you can do an activity now? I want you to try. Right, let's do the activity. And then after this, we are going to discuss, and then we take a short break. We go to homework. Let me give you 2 minutes. You can discuss in 2s or in 3s or in 4s, not more than that. Right, 2 minutes, find H1, H3, G4, and G2 with reasons. Please statement and reason. And then after that, we'll discuss. Then after our discussion, we'll take a short break, and then we come back and I give you homework and we summarize the lesson. Let's do that in 2 minutes. Discuss. Right, welcome back, Cretans. Let's discuss this. Right, what can you say about, this is angle G, this is angle H, G1 and H1. Right, H1, G1 is equal to H1, Y. These are corresponding angles. And then because AB is parallel to CD. Okay, so it means H1 is also 56 degrees. Please don't forget the statement and reason. Okay, that's the first one. Okay, you can complete this. I just wrote the first part, then you can say, therefore, H1 is equal to 56 degrees. And then H3, what can you say about H3 and H1? H1, angle H1 is equal to angle H3 because these are vertically opposite angles. Okay, these are vertically opposite angles. Therefore, H3 is also 56 degrees. Okay, then G4, how can you find G4? G4 and H3, G4, where's G4? Here. Okay, G4 and G1 are adjacent angles on a straight line. So it means G1 plus G4 is equal to 180 degrees. The reason, adjacent angles on a straight line. Okay, and then means it's going to be, now I have to use my head. What is 180 minus 56? 180 minus 50, that is 130. Is it 124? Please can confirm that. 124. I think it's 124 degrees. So it's 124 degrees. You see that? You can write, complete that. And then G2. Oh, G2, what can you say about G2 and G4? They are vertically opposite. So G2, just like we did H1 and H3 there, G4 and G2 are vertically opposite, so meaning that G2 is also 124 degrees. Okay, right. Okay, then you can just do the rest. You can also find these and find that if you have spare time. Okay, right, let's take a short break, and then after break, I'll go to the homework page, and then after that, we summarize our lesson. Let's take a short break.
The road to success is to commit to yourself. In order for you to become who you want to become as a student, you need to commit to reading your books, to studying, to bettering yourself. I know it's not going to be easy. Actually, no one said it's going to be easy. But if you put in the work, the results will show in your life. Tap into your power. Sometimes you will feel like putting away your books, and not reading as much as you're supposed to be. But I want you to commit, because through commitment, there is infinite power.
Right, welcome back, Cretans. This is our homework. You can pause the video here and take the homework and copy the homework. And then once you're done, you go to the summary, continue. And then we go to the summary. Let's summarize all this. This is our homework. Please do it and submit your work. Right, and then let's summarize. We didn't do a lot of interaction today, Cretans. Please, next week, let's try to engage each other. Okay, let's try to engage each other. So we say that adjacent angles on a straight line are supplementary. It means they add up to 180 degrees. Vertically opposite angles are equal. Angles around a point add up to 360 degrees. If lines are parallel, then corresponding angles are equal. Alternate angles of parallel lines are equal. And then if lines are parallel, co-interior angles are supplementary. Okay, that's what we learned today, or that's what we revised today, because it was about revision. Thank you very much, grade 10s. Let's meet next week. Oh, by the way, next week, Thursday is a holiday, but the lesson will be there. Okay, the lesson will be there for Thursday next week. We are revising geometry of triangles with revision, but geometry of what? Triangles. Okay, let's meet in our next lesson, grade 10s, and enjoy the rest of your day.